Alright, one of the essential tools that you'll need for Algebra 2 trig or pre-calculus or upper level math classes is the ability to complete the square. Let's just review a little bit of the purpose behind it and why you might need it. Here's a couple examples. These are two quadratic equations, and notice that they look kind of different because this one is in what they call maybe standard form. A lot of books call the standard form, and this one is in what some books call vertex form, because very easily you can pick out your vertex to be +2 and -3. I'm not going to teach you how to do that, but that's what that is. If you wanted to find the vertex for this parabola, these are both quadratics, so they're both parabolas, you would have to do a little bit more work, and so that's one reason why completing the square would be good. Another reason is because you can see if I wanted to solve this equation right here, if I wanted to plug in 0 for y to find the x-intercepts, it would be a lot harder to do that problem than it would be to do this one over here, plugging in 0 for this one. I can easily solve this because notice I only have one x there. Here I have two x terms, an x squared and an x. So in order to solve this, I either have to factor it or use the quadratic formula or complete the square so that it looks like this problem. In fact, these two equations are the exact same equation. One of them is in standard form and one of them, the square has already been completed. How easy this would be to solve: I add 3 to both sides, I take the square root of both sides, don't forget the plus or minus, and then I get rid of the 2 by adding it. There's my two answers, 2 plus or minus the square root of 3. Very, very easy to do if your algebra skills are good. So let's talk about how to complete the square. So again, we had x squared minus 4x plus 1. Here was my example. And let's pretend like, let's say that they aren't giving you y equals, they're telling you that 0 equals. It doesn't really matter. The process is the same. I'm going to teach you the way I like to do these problems. First, I'm going to separate out the squared part, and I'm going to add something, and I'm also going to subtract that same thing on the same side of the equation. And that something that I'm going to add and subtract is 1/2 of b squared. So half of b would be -2, squared would be +4. I put it there and there. Notice that I've added it, but I've also subtracted it. So I haven't actually changed the value of my equation. I've just made it look different, kind of like taking 1/2 and turning it into 3/6. It's the same fraction, it just looks a little bit different. Now that I've done that, I'm going to factor this, and notice that it factors nicely into x minus 2 squared, and these add together to give me -3. And you'll see that that's exactly what I had over here. So that is my equation after I complete the square. Let's try another one a little bit more complicated. Let's complete the square for this example. You'll notice this one's a little bit more difficult, and the reason is because this term right here in the middle, b, is not even. So when I go to do my problem, again, I'm going to set it up the same way as I did before. I'm going to leave a little bit of space there, and I'm going to add and subtract the same thing. When I take half of this, it's now a fraction. And so a lot of people hate using fractions, but I'm going to show you that you don't have to worry about fractions. It's just going to be 3 halves, or -3/2 squared, which is going to be 9/4. And again, I'm subtracting also 9/4. Now, I don't have to think too hard about this because when I complete the square, it's simply going to be whatever's in here is what's going to go inside my parentheses. That's how I completed the square. Now this is maybe a little bit more complicated, but it's not too bad. 1 is the same as 4/4, so this is just -5/4, and there I've completed my square. Let's try another example, a little bit more difficult, or maybe not more difficult, but a little bit different. So again, I'm going to take the 2x squared out. You'll notice this is different because I have to factor out, should have done this first, I have to factor out the 2. So the reason this is a different problem is because these other examples we looked at, the leading coefficient was 1. On this particular problem, the leading coefficient isn't 1, so I have to factor it out first. And of course I have to factor it out of both of those x terms. So you'll see that that's what I've done. And the trick here now is, since I factored it out of both of those, whatever I add in here, which by the way is going to be half of this squared, so that's going to be 9. I'm actually not adding just 9, I'm adding 2 times 9. So I have to subtract 2 times 9. Because again, when I factored out the 2, that's what I have to do. Not a problem. That was easy to be done. There's my answer. And negative 2 times 9 is negative 18. 5 minus 18 is negative 13. And there's my answer after completing the square. Let's try one more problem, a little bit more difficult this time. This is a doozy because now not only do I have a number in front of the x squared term other than 1, but it's not a factor of that, and also it's not going to be even, so I'm going to have all kinds of fractions and issues, but again, not a big deal. Let's just do it one step at a time and make sure we do it correctly. I'm going to factor out a 3. Notice that factoring out a 3 from 7 gives me 7/3. Now I'm going to add something and subtract 3 times that from the outside because I have the 3 here. And that's going to be half of this squared, which is 7/6 squared, or negative 7/6 squared. And so that's going to be 49 over 36. That's 7/6 squared, or negative 7/6 squared. And by the way, I can cancel that 36 and that 3, and I'm going to be left with 12. That'll make it easier for what I do in just a second. So this is going to be negative 7/6 squared. I don't write it out because all I'm really going to do is put negative 7/6 right here. And then on the outside, let's do this little math up here. 1 is 12/12. So 12 minus 49 is going to be 37/12, negative 37/12. And there's my answer, assuming I didn't make a silly mistake. So that's how you complete the square. You'll also use completing the square extensively when you're doing conic sections, because with conic sections the standard form equations are always in vertex form, meaning you need to combine this square. If you have an x squared and an x term, you need to combine those together by completing the square, and you have to do the same thing if you have a y squared term and a y. In fact, let's look at one of those examples. If you haven't done conic sections yet, you can ignore this part, but if you have, you'll understand what we're doing here. So I'm going to put in the typical equation that you'll see something like y squared minus 4y plus x squared plus 6x minus 3. So this is going to be a conic section, and completing the square a couple times, I'm going to have to complete the square on this and on this. I shouldn't have put y over here. I should have put 0, by the way, because the y's are already on the other side. Alright, so my equation is going to be, again, I'm going to set it up. I like to set it up like this. I'm going to add something here, but I'm also going to have to subtract that same thing from the back of it. And then I'm also going to set the same thing up with the 6. I'm going to add something here. I'll change the color so you can follow. I'm going to add something, and I'm also going to subtract it from the same side. Alright, those things I'm going to add and subtract are going to be half of that squared, which is 4. And for this one, it's half of 6 squared, which is 9. And so my equation, notice this factors now into y minus 2 squared, plus this factors into x plus 3 squared, and this adds it together into negative 16. Now usually with conic sections they'll actually have these on the other side. It's the same problem essentially, but basically this can just be moved over to the other side by adding 16. And so there's my equation. There's my conic section. And if you know anything about conic sections, you know that's a circle with center -3, +2, with a radius of 4, because the square root of 16 is 4. But if you don't understand that, you eventually will get to it. There it is, completing the square with some application. Good luck.